Hi everybody, we are going to find the surface area of a pyramid. So what is a pyramid? Well, a pyramid has one base, and the base could either be rectangular, it could be triangular. So whatever is in front of this word, rectangular pyramid, the base would be a rectangle, or triangular pyramid, the base would be a triangle. So for right now, I'm going to stick to a rectangle. So I'm going to draw a rectangle for the base. Okay, now it only has one base, so I'm just going to draw a dot at the top, and this is going to make our pyramid. So just connect this vertex to this vertex, and keep doing that with each vertex, that was off a little bit. Okay. All right, so this is a pyramid. It has a rectangular base, or it could have a triangle on the bottom, but the main thing is, in order for it to be a pyramid, it has to have just one base. What we're going to do is we're going to find the surface area of this pyramid. That means that if you were to take this and dip that into chocolate, how much of the area, the outside area, would be covered in chocolate? Now the chocolate would not seep inside, because that would be volume. So we're not going to do the inside area, the volume. We're just going to do the surface area, just the outside area. All right, so here we go. Let's label a few things. Sorry, I got caught by my phone cords. Okay, we're going to label a few things. Let's label this. Now these are not going to be to scale. 6 meters. This can be 2 meters. All right, and then we need the height of each triangle, and we'll just label this height as 10 meters. Okay, what I'm going to do is I'm going to draw the net figure of this picture. So if I were to cut all of these and then just lay them out, what would it look like? Well, let's see. We would have a rectangle here. Let me move this over a little bit. We'd have a rectangle here, and then if I were to cut this and lay that flat, it would go down like this. And if I were to cut the back and lay it back, it would go like this. Cut the side, so if I were to cut this side wall, it would fall down. And the same thing with this side right here, it would fall that way. Okay, now let me move this over a little bit more. Let's label everything. Okay, so this was 6 meters, 6 by 2. So I'm going to label this as 6, that's that length, and this was a 2. Now, each triangle is about 10. Oh, and I forgot my little 90-degree box to show it's the height. This is the height of the pyramid. So this is the height of all the triangles. That's 10. This would be 10, 10, and 10. Okay, now in order to find the surface area, that means we need to find the area of this flat figure. So these are the parts that would be affected by the chocolate if this whole 3D figure is dipped into chocolate. So let's find the area of this rectangle first. This will be the easiest part. All right, moving down here, we're going to find the area of the rectangle. It's 6 and 2. All right, the formula for the area of a rectangle would be area equals base times height. So the area would be, this is the bottom base, 6, and we're going to times it by the height of 2. And 6 times 2 is 12. Now I'm going to put a little box around that because I need that information for later. And actually, I can write that. Let me get a different colored pen. I can use a red. The area of this part right here is 12. So I'm going to write that in here so we don't forget that. All right, now let's take this triangle right here, this upside down triangle. The base is 6 and the height is 10. So I'm going to draw that. Okay, so the base is 6 and the height is 10. All right, let's try and find the area. It's very similar to base times height, but if you have a triangle basically, if I were to cut any rectangle in half, you'd get 2 triangles. Okay, so a triangle is half of a rectangle. Well, here's the formula for the area of a rectangle, base times height. So we have to cut it in half, divide by 2, in order to get that triangle. Okay, area equals, the base of this triangle is 6, the height of the triangle is 10, and then we're going to divide it by 2. Okay, 6 times 10 is 60, divide it by 2 though, and we get 30. All right, that means that this triangle has an area of 30. So I'm going to go find the triangle right here, the 6 by 10, and that was 30. Now I have a lot of students that are probably yelling at their computer right now saying, don't divide it by 2. And the reason that some of them don't want to divide this particular problem by 2 is because in a minute we're actually going to times this by 2 because here is an identical triangle. So this is 30 and this is 30. So 30 plus 30 will be 60. So they wouldn't have divided it by 2 because they know, oh, in a minute we're going to times it by 2 anyway because we have 2 of them. But we're just going to keep going. Okay, so this is 6 by 10, and so is this one, 6 by 10. So I already found the area, it's 30. Okay, we just have one more triangle to do. This is a 2 by 10, and so is this. This is also 2 by 10. So I'm just going to do it one time. 2 by 10. Let's draw it. Okay, 2 by 10. So here is the formula for the triangle. Area equals the bottom base times the height, and we're going to divide it by 2. Area equals the base is 2. We're going to times it by the height of the triangle, and then we're going to divide it by 2. 2 times 10 is 20. Now we're going to divide it by 2, and we get 10. I always don't have my answer on there. Okay, 10. So that is the area of the triangle, 10. So right here I'm going to write a 10, and that's the area for that one. Now these are identical, so this is also 10. All right, so basically what we've done is we've opened up this pyramid so we can see all the pieces laying flat. Then we found the area of each shape, whether it was a rectangle or a triangle. And now what we have to do is find the whole area of everything, all the surfaces. So we're going to add all the areas up. 30 plus 30 plus 10 plus 10 plus 12. All right, well, 30 plus 30 is 60, 70, 80, 92. So the surface area will equal 92. Now, you still have to have a unit, so it's a meter. So we're going to have a meter right there. And because we're dealing with area, whether it's surface area or just regular area, it's always squared. Because we're dealing with a two-dimensional object. Here's length and, base and height. That's all we're really dealing with. Even over here, even though this is a 3D object, we're only doing the flat pieces. We're not doing the 3D object on the inside because that would be volume. All right, so the surface area is 92 meters squared. Now what we're going to do is do the same problem, but instead of a rectangular pyramid, we will do a triangular pyramid. Okay, it's basically the same thing, so if you want to turn the video off, you can. The only difference is that with a triangular pyramid, let me write that down. Did I spell that wrong? I did. Oh, man. Let me get a new, hold on. Let me turn it upside down. All right, with a triangular pyramid, let me make sure I spell it correctly. P-Y. Oh, there we go. With a triangular pyramid, we are going to have the base is going to be a triangle. Okay, and a pyramid means it has one base. Now, the base of this triangle could be, it could be equilateral, where all sides are equal. That's equilateral. It could be isosceles, where two sides are equal, but the other one is not. Okay, and the way you spell that is I-S-O-S-C-E-L-E-S. I-S-O-S-C-E-L-E-S. It could be scalene, where all the where all the sides are different. Scalene, and this has the word scale in it, scale, and then N-E, or it might even be a right triangle. And I hope it is a right triangle, because if it has a right triangle, we have that height immediately. And this is called a right triangle because it has a right angle right there of 90 degrees. All right. Now, if it doesn't have a right, if the pyramid does not have a right triangle on the bottom, we're going to have to hopefully see where the height is. They're going to have to label it somehow so we can see where that height is. All right, well, luckily I'm the one in control of this pyramid, so I'm going to make it a right triangle. Okay, let's see if I can draw it correctly. I'm going to draw a right angle, so this is the right angle, And then I'm just going to connect it. Oh, I should have done isosceles, but that's okay. All right, let me label everything. This is going to be a 4, a 6. This can be, let me see, an 8. Definitely not drawn to scale. All right, and we'll label it as inches. And then I'm going to have a dot right here as the vertex. Connect this vertex to this vertex. And connect all of these, and there's our pyramid. So the pyramid has one base on the bottom, and then it has 3 sides going around, 3 faces. Okay, so we still need a little bit of information. I can find, let me see, I just zoned out, sorry. We can find the surface area of all of these, but we need the heights of all the triangles. So I'm going to draw this line going up, and again, I'm just going to label it as 10 as the height. All of these heights are 10. All right, let's try and find the surface area. So first we're going to draw this figure over here. We're going to do the net figure of it so we can see it all laid out. So I'm going to draw this picture first. Not quite drawn to scale, but that's okay. So this is the picture right here, and I'm going to label it so I don't forget what the numbers are. 6, 4, and this was an 8. All right, then what I'm going to do is I'm going to take on this side of 6, I'm going to cut this triangle off and lay it down. So that's going to go out here, and that had a height of 10. On this long 8 side, I'm going to lay down that back triangle. And again, it has a it has a height of 10. Okay, and then I'm going to take this front side and lay that down. And it still has an area of 10. All right, so we have all of the figures now, and unfortunately in a triangular pyramid, everything is a triangle. So we have a lot to do, and I don't think anything matches. We have a base of 4 and a height of 6 here, a base of 8, a height of 10, a base of 4, a height of 10, a base of 6, a height of 10. We have all different triangles. Okay, so let's take the first bottom one. So I'm going to take this triangle off to the side. Okay, and we have to look at what it is. So it is a 4, on the bottom is a 4, and then going up is a 6. Just like over here, it's a 4 with a 6. This 8 is not going to be important for finding the area of this, so we don't need that. 4 and a 6. Okay, finding the area of this triangle. Area equals base times height, but because it's a triangle, we have to cut it in half. So area equals the base is a 4, times it by the height, which is a 6, and we're going to cut it in half. 4 times 6 is 24, divide by 2, and we get 12. I'm going to put a box around that so I can remember it. And I'm going to label the area in here with a different color. This area was a 12, and I'm going to circle it so I can see it later. All right, next one. Let's take this one. We're going to take the big one. Oh, this is even bigger. Let's take the really big one. 8 by 10. Okay, so the bottom was an 8 and the height was a 10. We're doing this triangle right here. Area equals base times height, and we have to divide it by 2 because it's a triangle. The base is an 8, the bottom 8, and then the height is a 10. And we're going to divide it by 2, and we get 80 divided by 2, which is 40. All right, then I'm going to put my answer here so I have it. All right, next, I'm going to move this paper real quick, sorry. Oop. All right, next one is this one, the 6 by 10. So we're going to draw the triangle. I'm going to go a little bit faster because I think my time is running out. I need to make it under 20 minutes. Okay, area equals base times height divided by 2. Here's the base of 6, the height of 10. Okay, and 6 times 10 is 60 divided by 2. Oops, and we get 30. So that's going to be a 30 for this one. And our, and our last one is a 4 by 10. So let's do that one. Okay, area equals base times height divided by 2. The base is 4, that's the bottom. The height is 10, and we're going to divide that by 2. we get 40. I think it's not sliding. 40 divided by 2, which is 20. All right, so going back up here, that means the area of this one is 20. Now, to find the surface area of everything, we have to add all of these up because we want to know the whole surface, the whole area of all the different surfaces. So 40, 50, 60, 70, 80, 90, 100, and 2. So the surface area would equal 102. The unit is inches, and because we're still dealing with area, we're going to have inches, let me move that over a little bit, inches squared, and that would be the final answer. All right, thank you for watching.